Hello and welcome to my presentation on designing a polyomino interface for pitch lattices. It is an interface that allows you to explore chords, pitch systems, and pitch drift in a novel way. You play notes by placing polyominoes on a grid of AprilTech markers. This is a grid of AprilTech markers. They look somewhat similar to QR codes and pictograms. However, the only information they encode is a number. Let us take a closer look at what these numbers can do. This is a set of 9 adjacent AprilTech markers. For now, let's focus on these 9 markers to explore the basic functionality of the Polyomino interface. For orientation, let's remember the AprilTech in the middle as the frog face. The Polyomino interface uses computer vision to detect the AprilTech markers. As we have seen, each AprilTech marker encodes a number. Each number corresponds to a unique note that is played according to a set of rules. To the right, we increase the note's pitch by 1/3. Upwards, we increase it by 1/5. The frequency of each note is calculated based on the rules of 5 limit just intonation. To the right, the thirds are in a ratio of 5:4. Upwards, the fifths are in a ratio of 3:2. All of the fundamental frequencies of the grid are calculated with respect to our frog face AprilTech. Its pitch is the middle C. If we want to calculate frequencies further, we just multiply the ratios. For diagonals, we do the same thing. For the other direction, we simply switch the ratios. So where do the polyominoes come in? We can use the polyominoes to cover fields of the grid. These fields are then detected as missing or covered, and we can find the notes associated to each field. Changing the orientation of the polyomino can change the chord that's played. The interface flow of information starts with placing the polyominoes on the grid. A camera films the scenes and a Python script detects which fields are covered by the polyomino. A C-sound script then takes the information which notes to play from the Python script via OSC, Open Sound Control. A physical interface with 2 sliders and a button is used to send additional information to the C-sound script. One slider controls the volume, one slider controls a fade between 5 limit just intonation as we have discussed it previously, and 12-tone equal temperament. The button updates the notes that are played in C-sound when pressed. Let's take a closer look at what the Python script does. We start with a value of 261.63 Hz for our middle C as the position of our frog face AprilTech marker. Then we populate a row with values using our 5:4 ratio of thirds. Then we populate the columns with values by using the 3:2 ratio of the fifths. Frequency values that exceed 500 or are below 100 are halved or doubled until they are within the boundary again. The Python script then populates an array with the 12-tone equal temperament values as well. First, we fill the whole array in a similar manner as before, however without frequency boundaries. For each field, we then find the closest octave of the 12-tone equal temperament array to the 5-limit array. Moving our morph fader changes the pitch of the notes that are currently playing. To update the notes, press the button. This is the design for the physical interface. Now let's listen to some more sounds.